Okay, on the yellow sheet of paper I passed out to you, I've given you the 4 scenarios of what can happen if you have an absolute value within an inequality problem. First one and the second one are the ones that actually matter a lot. The last two are more trivial, but they do happen sometimes. The first priority in every single absolute value inequality is to get the absolute value expression all by itself greater than or less than a number. Whether it be a positive number in this case or a negative number. Your first priority is to get that absolute value expression simply put all by itself on that one side and then greater than or less than another number. So, I use the letter P to designate a positive number. So what does negative P look like? If P is a positive number, negative P looks like a negative number, right? So, for example, if I have the absolute value of x is greater than 74, does everybody agree 74 is a positive number? Yeah. All right. So absolute value of x is greater than 74. That means that x is greater than 74 or x is less than negative 74. That's all that means. I don't want to have absolute value expressions in an inequality, so that's how you get it out. You change an absolute value expression into a disjunction. Or, absolute value of x is less than, let's say less than or equal to 62. Everybody agrees 62 is a positive number? All right. So this is saying to go from here to a not absolute value expression, I'm supposed to create this structure. Whatever this number is p. So I put minus p is less than x is less than p. That says less than or equal to, so equals equals. Right? So again, I don't want absolute value expressions, so that's how the absolute value expressions disappear. This is now just x, not absolute value of x. If absolute value of x is less than 62, that means that x is between negative 62 and positive 62. If absolute value of x is greater than 74, that means x is greater than 74. Where that 70 came from, 74. Or x is less than negative 74. All right? The other two scenarios is absolute value of x is greater than a negative number. Okay? Absolute value equals 0 or bigger. The absolute value of 0 is what?
0.
Absolute value of 5 is?
5.
Absolute value of negative 72 is?
72.
Right, every answer is positive, right? Or 0. So the smallest this could possibly ever be, so if we're looking at this guy right here, the smallest that can ever be is 0, right? So some number either 0 or bigger is greater than negative 10. Always true. All real numbers. All right? If you're graphing all real numbers, just graph the entire number line, put the arrows shaded. If the domain is a set of integers, dot off all the integers and put the arrows shaded. All right? Same scenario here, except now we got less than a negative number. So absolute value of x is less than, let's say, negative 14. This is 0 or bigger, right? Some number 0 or bigger is less than negative 14. Impossible. Empty set. Never true. So again, those are the 4 things that can happen. Absolute value expression, inequality, number. That's how you fix it. And let's do a couple. Pretend you don't see that. All right. Graph absolute value of x is less than or equal to 4, domain set of integers. Worry about the domain after we get it solved, but you can see we already have it solved, right?
Yes.
Right, absolute value less than or equal to 4. We want to create a non-absolute value expression. So that's case 2, right?
Yeah.
So case 2 says we have less than a number. We're going to put the negative number is less than x is less than the positive number. There's an equals to, so we're going to put equals to on our conjunction. Okay, that's the solution without absolute value bars in it. Then we want to graph this on the domain of integers. So if the domain is a set of integers, I need to graph only integers. That's closed circles everywhere, no open circles anywhere, because integers don't have any kind of ambiguity to them. They're just definite starting points and ending points. Am I going to include negative 4?
Yes.
Why?
Because it's equals to.
It says equals. So negative 4 is an integer, and it says equals. All right, am I going to include negative 3?
Yes.
Yeah, because it's between them, right? And along with all these other numbers between. And of course, we're going to include positive 4. So negative 4 and positive 4 are the boundaries. included because of the equals, and then of course I'm going to put here and here and here.
Why couldn't you just do a squiggly thing?
Because it says integers, and if you squiggly it, then you're including all the decimals and fractions that aren't integers. So when you're graphing integers, you have to graph only integers. Okay? One of the things that happens with integers sometimes, let me just show you this. Suppose I get the absolute value of x is less than, let's say, 1/3. Let's make it 4/3. 4/3. Right? 4/3 is a positive number, right? Negative 4/3 is less than x is less than 4/3. Right? Where are negative 4/3 and positive 4/3 located on the number line? Between what and what?
0, no, sorry, -1. No, sorry, -2 and 2.
Negative 2 and negative 1, right, would be negative 4/3 would be about here. And between 1 and 2, positive 4/3 would be about right here. Does everybody agree with that? If I'm graphing just integers and x is supposed to be between negative 4/3 and positive 4/3, what's the first integer that makes it true?
-1.
Negative 1. And of course 0 is between them and 1 is between them. Even if you get fractions in your inequality, you can still graph integers that are within those fractions boundaries, okay? So keep that in mind. No open circles when you're graphing integers though. Alright, so I just want to make sure that there's no misunderstanding. I'm still getting a few of you putting open circles on integer graphs. I don't want to see them. The reason for an open circle is I want to get close but not touching. There's no doubt with integers. It starts here, it ends there.